Hello everyone, this is V. Manikyala Rao working as Assistant Professor in the Department of CSE and ML in BVRIT in Asapur. Now today we want to discuss about a classification by backpropagation algorithm. So actually backpropagation means came from the artificial neural networks. Actually we are having biological neural network and artificial neural network. In biological neural networks we are showing all are in the neurons format, but in backpropagation we are having three layers. First layer is input layer, and second one is hidden layer, and third one is output layer. These are the three layers are there. So based on this three layer format, we need to implement the backpropagation algorithm. So actually in the backpropagation we are having three steps. First one is forward propagation of the input data. So here x1, x2 are call it as inputs, h1 and h2 call it as hidden layers, and y1 and y2 is call it as output layers, b1 and b2 is call it as biases. Based on these three we are getting. Forward propagation means input to hidden layer and hidden layer to output layer, that is forward propagation. Then backward propagation is, for example, we are given the target value 0.01 and 0.99. These are the observed given values. Now after solving we are getting the t1 value is some 0.75. T2 value is some 0.78. We are taking the values like this. So the obtained value and the given values both are not same. Now we are getting some error. So at that case we are using backpropagation algorithm. So by using backpropagation, what we have to do means we need to do output layer to hidden layer and hidden layer to input layer. This is called it as backpropagation algorithm. Then after that we need to update the each and every weight after calculation of each and individual weight from the given classifications. Now see one by one. For example, these are the input values, they are given in the given structure. Based on that we need to calculate H1. How we are calculating H1 means, see here, H1 connected lines with H1. So that is W1 with X1, next W2 with X2 plus B1 is also connected. So based on that I return the formula for H1 like this. And the value is substituted into this one. Finally we got the H1 value is 0.375. This is called it as activation function. Activation function value. Next one we need to calculate sigmoid function. Based on the sigmoid function only we need to substitute into our equation. So that is 1 by 1 plus e power 1 by h1. So h1 final equal to 1 by 1 plus e power, this value we need to substitute to get 0.5. This is a h1 final value for this one. Similarly we need to calculate for h2. So h2 also incoming lines connected with h2. Based on that we are getting the value of h2 and finally we got h2 final. So finally we got this value is also 0.5. That is from, we are calculating from x1 to h1 and x2 to h2. Two calculations we are done. Now we have to do for the next step. What we have to do? Now we need to calculate for h1 to y1 and h2 to y2. The lines connected with y1 and the lines connected with y2. So lines connected with y1 and y2. So now we have h1 value we are already having. That's why I written h1 final into with respect to weight, then h2 final with respect to that weight with plus biased value. And after substituting we are getting the y value is 1.10. Then we have to calculate the sigmoid function, so that value we are getting 0.75. Similarly we need to calculate for y2 also. So y2 we are calculating, then the y2 final value is 0.77. So based on this y1 and y2 values, whatever the values we are given, actually in the problem we are given t1 is value 0.01 and t2 value 0.99. So y1 equals 0.75. So this t1 and y1 value is different and t2 and y2 value will be different. That's why we have to calculate the errors. So now we will calculate the error, then we will move into the backward propagation. I already explained. Backward propagation means we need to calculate from y1 to h1 and then h1 to x1. So error in total, target minus output whole square. Target means we are having two values, t1 minus y1 final and t2 minus y2 final. Substituting this one, the error in this problem is 0.2983. By implementing backward propagation, we need to reduce the error and update the weights. Now we have to calculate this error with respect to that one, means we need to calculate error with respect to weight. So delta E total by delta W. So this is called as partial derivative with respect to the total. So E total with respect to weight 5. Why we are taken with respect to weight 5 means the y1 to h1 the connected weight is W5. That's why we are taken W5. So actually we have to know, already know error total value means this one. Then we have to substitute. So directly error total with respect to weight 5 is not available in the given formula. Now what we have to do means we are having the values of H1. That's why with respect to Y1 final, with respect to Y1 final to Y1 and Y1 with respect to W5. So now individual we need to calculate with respect to Y1 final, with respect to Y1 and with respect to weight 5. Then we have to substitute into the equation. Finally we got the value of error in total with respect to weight 5. So first we need to calculate, so we already seen. So with respect to Y1 final means Y2 final is the constant value. So now that value is 0. So x square means 2 into x power n minus 1. N into 2 into x power 2 minus 1. That is the partial derivative formula. Dou by dou x of x square means 2 into x power 2 minus 1. So that's why 2 into that particular half into x power n minus 1. So finally we got that value is 0.75. That is error total with respect to Y1 final. Now we need to calculate Y1 final with respect to Y1. So actually we already know Y1 final equal to 1 by 1 plus e power minus Y1. The derivative we are doing after that e power minus Y1 by 1 by 1 plus e power minus Y1 whole square. Then we are substituting into the equation. We already know 1 by 1 plus e power minus Y1 and means Y1 final. That's why we are substituting into this. Finally we got e power minus Y1 value like this. Then we need to calculate that one. We are obtaining that value as 0.18. Next, similarly, Y1 with respect to Y1. So Y1 formula we already know. So with respect to W5 means these W6, B2, these all are constants. So these all are constants. So that's why this value is 0. So with respect to W5 means this value 1. So finally we got H1 final. That value is 0.59. Then now what we have to do means the product of those all, we are getting that 0. With respect to error in W5 is 0.082. Now W5 with respect to new value. So W5 minus eta into with respect to W5. So eta value is 0.5 after substituting 0.3589. Actually in the diagram, in the example we are taken W5 value is 0.40. Now that value is updated to 0.35 at the value of implementation of backpropagation algorithm. We are doing that one. So actual value we are taken as 0.40 but updating that value with 0.35. Similarly, same process we are doing, we need to update the values of W6, W7 and W8. Some of the 0.05 difference between all the points. Similarly, we are calculating this one for Y1 to H1. Now, we need to calculate the error with respect to H1 to X1 here. This is the H1 to X1. So, H1 to X1, the weight connected is W1. So, that with error in total formula is this one. Now, we have to do the same process for W weight 1. So, same process, previously we are having Y1 and now we are having H1 final. So, with respect to H1 final we are doing and then we need to calculate that one. So, here next W in total with respect to H1 final, that is after calculating this one is belongs to error 1 and this one is belongs to error 2. So, that's why I written the same formula here. Now, we have to do the same process here with respect to the continuation. So, delta E1 by with respect to H1 final is not available directly. That's why we are dividing that one into with respect to Y1 and with respect to Y1. H1 final is connected to Y1. That's why we are taken Y1 and H1 final is connected to Y2. So, that values we are written. Then we are substituting into the formula. Finally, we got E1 with respect to Y1. That values are 0.13 after substituting into our formula. Now, similarly, we need to calculate E2 with respect to Y2. And then that formulas we are written here. Next Y2 final means 1 by 1 plus e power minus Y2. Then finally e power minus Y2 equal to 1 minus Y2 final by Y2 final. And substituting this equation, finally we got that value is 0.175. And now that updated delta E2 with respect to Y2 is minus 0.038. Now next one, E1 with respect to H1 final, that values we are getting after substituting into the equation. So it will be executed with respect to H1 final. That's why this value will be 1 and these all are constants. So with respect to W5 only there. So W5, that value we are written into that particular value 0.055. And finally after substituting into the equation, finally we got this value is minus 0.019. Now after taking these all the values, now we are calculating e power minus H1. Why? Because now we have to calculate H1 final with respect to H1. So that is equal to minus e power minus H1 by 1 plus e power minus H1 whole square means that value is H1 final, this value. So then we have to take e power minus H1 means that will be written like this. After that, now we have to substitute into this, we got the value 0.24. Now here delta y1 with respect to y1. So here with respect to w1 means the value we are getting as x1. So that x1 value is 0.05. These all are constant values. Finally, after calculating these all the values, now we have to update the weight new value. So 0.15 minus 0.5 into 0.4043. So finally we got that value is 0.149, that is W1 new value. Actually that value we are taken as 0.05. Then that values will be updated like this. It's W1, W2. Actually this value we are taken 0.15 and that actually we are getting that updated value is 0.14. Like this we are taken these all the values updated. We found that error is actually that error value is this one. After doing 10,000 iterations, the given error value is reduced to 0.2910. 2983 will be reduced into 2910. If you have to do more number of iterations, the error value will be reduced, the updated value. So after doing that one, the values we are obtaining is 0.15 and 0.98. These two values are near to these two values. That's why we have to stop the process. That is about classification by using backpropagation algorithm. We are doing forward propagation and backward propagation, and finally we have to update the weights for the given variable values. This is about classification by backpropagation. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.